physics of the atom is 50 years before the general societal condition called the ecology crisis. You've seen the breakdown of the description of parts.
Yes, probably. Yes, it began to be clear about 1930 or so. You see, with Einstein, Rosen, Podolsky, it was already implicit, right?
That's 35.
35, but people had a feeling for it perhaps before, I mean, without expressing it.
So why could physicists see this breakdown of the description in parts 50 years before general society?
Well, they were working on a rather restricted area where the evidence was such as to bring it out. You see, because the area was limited, it was possible to focus more on the problem, right? Whereas the whole social problem is far more complex, and it's so complex that people could always say, maybe it's not that way.
But isn't it still surprising that you are able to go from physics into more general problems?
Not to me, you see, because I think that's a sign of the wholeness. You see that there was a medieval view, which I think there was much more wholeness then. There was a medieval view that everything was an analogy to everything. You see, a human being was a microcosm of the cosmos, so that he had implicit in him the possibility of understanding it, right? And then you see that the general view before our modern times was more favorable to wholeness, right? Even in Europe and as well as in the East, right?
Niels Bohr's interpretation of quantum mechanics, which is the mainstream interpretation, it differs from yours.
Yeah. Yes, well, I wouldn't, I would say in some sense it's the mainstream, but I think not a great many physicists really understand it very well, because it's very subtle. See, originally I was very much in favor of the Bohr interpretation, which seemed at that time the best, and it's very subtle and hard to explain, but basically it emphasizes this wholeness of the observing instrument and what is observed, that they are one whole and they are one phenomenon. And now the thing and many of the things which he says would be on the lines which I have just talked about, right? That's why it attracted me. Now I won't go into more detail about it because it's very difficult, but the one thing I feel I didn't quite agree with was that he said that this whole was completely, there was no way of making a concept of this whole, you see. Right? And that meant that you could not make it intelligible. The mathematics would only refer to the probable results of experiments, would not discuss what is actually happening, right? Now, so I developed later in 1951 or thereabouts another interpretation where I said that the electron is a particle, for example, and then it has a field, what I'll call a quantum field, represented mathematically by its wave function. And this field and the particle are together, and they account for the properties, the quantum properties of the electron. It's a new kind of field, right? Now, we know classically we have many fields, like the electric and magnetic field. The magnetic field, for example, you see iron filings showing how it spreads through space. The electric field, the electromagnetic field makes radio waves radiating through space. But the quantum field is different. It has some similarities, but it's different because the effect of the quantum field depends only on the form and not on the intensity, you see. If you think of a water wave, it's spreading out. If the cork is bobbing, the more it spreads out, the less the cork bobs. Now, the quantum field would be capable sometimes of spreading out, and the electron far away could move with the same energy as if it were close. This would be a kind of explanation of this discrete quantum process.
So you have a field that doesn't drop off when you go
towards... The field drops off, but its effect does not, you see. The effect depends only on the form, right? Not on the intensity.
That's weird.
It's not so weird. In fact, it's very common, but we generally don't pay attention to it, you see. You see, if you take, for example, a radio wave, its effect falls off. Now imagine a ship guided by radar on an automatic pilot. The guidance does not depend on the intensity of the wave. It depends only on the form, which carries, we may say, carries information. the word information has the two words in form, to put form in, right?
So it's like if you have a television set and you go far away from the antenna or the place where they put out the broadcast.
Yeah.
It doesn't mean that you don't get the broadcast. You just need a bigger receiver.
Sensitive receiver, that's all, you see. So as long as it's received, it's essentially the same program, you see. So what happens is that the form of the radio wave puts form into the currents flowing in the receiver, right? The energy comes from the receiver, not from the radio wave, right? The radio wave is not pushing the ship around mechanically. The ship is moving under its own energy, you see, and responding with the form. So the radio wave is guided, is giving shape and form to its motion, you see. So this goes back to an old idea of Aristotle of saying that there can be a formative cause as well, right? Now this is very common. We have it not only in radio. The computer has a form which is carried out in the process of, it may run machinery. You can have DNA. The form of the DNA determines, is carried to the RNA and determines the making of proteins, and so on. And in all human experience, you see, people generally don't push each other, pull each other around, except when they're violent. They depend on the form of the sound waves to communicate, and the people move around because of that, you see. So the point is that this is the most common form of experience, and the mechanical business of pushing and pulling is more limited, but our experience of the past few centuries has led us to focus on that as the main point, right? And saying we can always explain the other thing through that. But I'm saying maybe it's that this form is fundamental, and that the electron responds with this form, you see. Now, that explains not only, it explains the interference, it explains why the electron acts like a wave, and it explains this non-local business, and so on, and explains the superconductivity as the electrons moving by a common pool of information, just as the ballet dancers do, and so on. So so that means we have quite a different principle of explanation, because this wave function, which operates through form, is closer to life than mind, you see. The basic quality of mind is that it responds to form and not to substance, right? And therefore, the electron has a mind-like quality, though it may not be, it's almost certainly not conscious in the sense we know, but consciousness may depend on much higher organization of this mind-like quality. So we could say it may have many new mind-like fields could arise, which we don't know, you see, in the human being or in life or in animals.
So what you're saying is that the physical universe is really more about information than about substance?
Well, I'm saying it's both, but information contributes fundamentally to the qualities of substance.
If you said things like this to Niels Bohr, how would he have responded?
I don't know. He might accept it, he might not. You see, we did have some talks when I was here at the Institute, but I didn't have these ideas. I didn't have this idea about information then.
But if we try to compare the way that you see quantum mechanics with your field that has an effect that doesn't go off with distance, with the interpretation of Niels Bohr.
Well, Niels Bohr would say that there's no way to discuss this at all, that there's nothing but a phenomenon which is a whole, and even including the two distant particles. We can only discuss the mathematics as giving the probability that certain results will be obtained, right? Now, I'm trying to say this gives an intelligible explanation, you see. Now, it requires you to accept new principles, and you would have to say that this wave field will perhaps have a more subtle substantial basis, which we don't know, that would carry it.
But basically what you are doing is that you are interpreting quantum physics, the physics of atoms, in another way than the mainstream.
Yes.
And then and there are certain technical points where people like Niels Bohr would disagree, because he would feel that you enter discussions that human beings really cannot enter.
I'm not sure why. You see, his whole Niels Bohr's discussion is